Hi, welcome to part 2 of this AP problem, where we will be finding mu, so the car does not skid, when the car is going 94 kilometers per hour, or as we said earlier, 26.1 meters per second. So, in order to do this, we first have to draw another free body diagram, because there's the added force of friction. So, we're going to draw our car. And now we have the force of gravity, mg, our normal force, N, and our force of friction going downwards of FF. Alright, now we have to do new summation statements. So we have forces in the y direction equal to N cosine theta minus mg minus mu sine theta equals 0, because the car is not moving in the y direction. Now we're going to solve for n, so we're going to move mg over to that side. So we have n cosine theta minus mu sine theta, mu n sine theta, sorry about that, mu n sine theta equals mg. Now we're going to factor out an n from the left side, so n times cosine theta minus mu sine theta equals mg. Then if we divide both sides by that big term right there, we're going to get n equal to mg over the quantity cosine theta minus mu sine theta. Alright, now we're going to do our summation statement for forces in the x direction. So forces in the x direction equal n sine theta plus mu n cosine theta equals ma, or since a is v squared over r, equals mv squared over r. Now again, we're going to factor out an n from the left side. So n times the quantity sine theta plus mu cosine theta equals mv squared over r. Now we're going to substitute our n over here in over here. So we get mg over cosine theta minus mu sine theta times sine theta plus mu cosine theta equals mv squared over r. Now our m's cancel out, and now we're going to multiply both sides by the denominator, cosine minus mu sine theta. So then we are left with sine theta plus mu cosine theta equals v squared over r times, sorry, there's a g on the left side too. So v squared over r times cosine theta minus mu sine theta. Alright, now since we have a theta on both sides of the equation here, we're going to want to distribute our two terms so that we can get both of our mu's on the same side. So now we have g sine theta plus g mu cosine theta equals v squared over r cosine theta minus v squared over r mu sine theta. Alright, now we're going to rearrange to get our mu's on both sides. So we're going to add that term on both sides to get it over here, and we're going to subtract our g sine theta over there. So then we have g mu cosine theta plus v squared over r mu sine theta equal to v squared over r cosine theta minus g sine theta. Okay, now we're going to factor out a mu from both sides, or from the left side. So we have mu times the quantity g cosine theta plus v squared over r sine theta equals v squared over r cosine theta minus g sine theta. Now if we divide both sides by g cosine theta plus v squared over r sine theta, we can solve for mu. So mu is going to be a big term of v squared over r cosine theta minus g sine theta all over g cosine theta plus v squared over r sine theta. Now if plugged into your calculator correctly, that should leave you with, that should give you a mu of 0.21. And there are no units on that because mu is just a constant. And that is the second part of this problem, and that's it.